Hi folks, well today before we get on with any maths we're going to have to think about books a bit because it's World Book Day. So the book I'd like to bring to your attention today is Catch-22 by Joseph Heller, which is a great book. They made a really good TV series of it about a year or two ago, which I well recommend, which was an amazing feat because it was one of those books which I really think is pretty much impossible to do, but they just about managed it. But the book is all about an American in the Second World War who's has to fly missions in a bomber from the south of Italy, and he's having to do this every day, and he's absolutely scared of dying. He's always looking for a way out, and then he hears that it's possible one of the people who's flying missions with has definitely gone mad, and he discovers that actually if you're insane you don't have to fly, even though they keep telling you you've got to fly, but there is a catch, and that catch is Catch-22. So I'm just going to read you a little bit of that now. There was only one catch, and that catch was Catch-22, which specified that a concern for one's safety in the face of dangers that were real and immediate was the process of a rational mind, or was crazy and could be grounded. All he had to do was ask. But as soon as he did, he would no longer be crazy and would have to fly more missions, or would be crazy to fly more missions and sane if he didn't. But if he was sane, then he had to fly them. If he flew them, he was crazy and didn't have to, but if he didn't want to, he was sane and had to. Yossarian was moved very deeply by the absolute simplicity of this clause of Catch-22 and let out a respectful whistle. "That's some catch, that Catch-22, he observed. "It's the best there is," Dr. Decker agreed. And that's it. Now, the whole book is about, as it goes on, he starts to feel that Catch-22 is being used for everything. In fact, he starts to think Catch-22 doesn't exist other than as an excuse for people to tell him that he can't have what he wants. And that's often what life feels a little bit like. But anyway, we've got some maths to get on with. Right, now I'm going to kick things off today by going through a question that a couple of weeks ago now I asked you to have a go at, and I said I wasn't going to go through it until someone had a go at it. Well, someone has done now, and they had a really pretty good go at it. So well done to you. I'm going to go through it now. So we've got to find out the surface area of the tank in meters squared, and then divide it by 4. And we've got this issue at the beginning. The diameter is given in centimeters, whereas the height in meters. Because we're looking at square meters, the best thing to do here is divide by 100 to make it 0.4 meters. So if I just cross that out and call it 0.4 meters, I won't get into it. And the person who did have a go did everything right except for that, meant that their answer was way out, but they did get 3 out of 4 marks, so it was all good stuff. Right, so first of all, let's consider the net that we would have. You'd have a long rectangle for the curved bit going around there, and then we would have a couple of circles. And the area of each circle is pi r squared. Now, the diameter is 0.2, so the radius is going to be half of that 0.2. And we've got 2 circles, so the circles are going to be 2 times pi times 0.2 squared. And if you put that into your calculator, you get 2/25 pi. Now, you could press S to D, but you don't need to at this point, so I would just call it that centimeters squared. And then all we need is to know what the length of the tank is. So that is going to be the circumference, the distance around the circle, isn't it? And circumference is pi times the diameter. We also know that the width of this rectangle is the height of the cylinder, which is 1.8. So the area of the rectangle is going to be the length, which is pi times 0.4, the diameter, times by the width, which is 1.8. Put that into your calculator and you get 18/25 of pi. So the surface area of a tank is going to equal 2/25 of pi plus 18/25 of pi, which is 20/25 of pi. That's which, if you put that in your calculator, that would be simplified to 4/5 of pi. But we don't have only one tank, we've got 5 tanks. So 5 tanks are going to equal 4/5 of pi times 5, which is 4 pi, which is 4 shift pi. At that point I would press S to D, which tells me 12.56, and then that number is what we need to divide by 4 for the 4 litres of paint. For each pot can cover 4 square meters, because it's that many square meters, and that gives us exactly pi, which is 3.14 pots. But that's not 4 marks out of 4, because you can't go into a shop and buy 3.14 pots. You would have to buy 4 pots. So if you put 4 pots, you get 4 marks, but you don't get 4 marks for guessing 4 pots. You would get nothing for that. You'd have to have the working behind it to back it up. Now, the question I asked you to upload me your effort at after last lesson was this one, and one person got this absolutely bang on 100% right. A couple of people had a good go at getting going. 1 or 2 people, their answers sort of showed me that it really didn't look like they'd watched the video at all. So whether I'm wasting my breath now, because you may well not be watching this video as well, the idea is not just to print off the worksheets and have a go at doing the worksheets. You need to watch the videos in order to learn how to do what you need to do on it, rather than just guessing. Right, so we should have this length is opposite that angle, and this length is opposite that angle. So we really want this angle here. You could do it by using Pythagoras to find that one, but we don't need to, because we know that these all add up to 180. These two angles must add up to 90, because the right angle is 90. So 90 take 35 is 55 degrees. So that's a 55 degree angle. And what that means, we can say, is that x over sin 35 is equal to 20 over sin 55. And sometimes people get confused about which one to put with which. I don't know if I made it clear enough, but the angle always goes with the sin. Then we need to get x on its own, so we multiply by sin 35, and what you put into your calculator is 20 sin 35 all over sin 55. And if you do that, that should be, just to make it really clear, that should look something like this: 20 sin 35, remember to close the brackets on the 35, over sin 55, close the brackets, and that gives us 14.004. I just write down 14.00 first of all, and then for 3 significant figures I write 14.0, because that's what it would round to, looking at the 1 in a second position there. Right, now we're going to carry on to question 6 and beyond. So have a look at this one, see what you make of that, pause the video, give it a go. Right, we want the length AB, so that's that one. That is opposite this angle over here, so we need this angle. I know that that is 90 degrees, that's opposite that one, so it's going to be x over sin whatever that angle is there equals 15 as the length over sin 90. Now what is that angle? Well, 42 plus 48 make 90, so that'll make 180 degrees altogether in the triangle, so that one there must be 48, so it's x over sin 48. You multiply both sides by sin 48 and you get x equals 15 sin 48 over sin 90, and that should give you 11.14, which rounds to 11.1 centimeters. Here's question 7. It's looking for an angle, so you're going to need to turn the sine rule upside down. Pause the video and give it a go. So remember, what I mean by the sine rule upside down is that the size of the angle over the length is going to equal the sine of the other angles over the lengths. So what do we know? We know that this is 90 degrees, and we know the one opposite it. So we know that sine 90 over 16 is going to be equal to, the angle we want is ACB, and that means that it's always the letter in the middle is where the angle's at. Sometimes they have a little sort of angle on top of it. So this is our angle, so it'll be sin x over 5, and then all we need to do is multiply both sides by 5, which gives us 5 sin 90 over 16 is equal to x, and put that into your calculator and you should get 5. Oh no, what have I done wrong? Shouldn't get 5/16. We've got it's equal to sine x, isn't it? And we need to get rid of the sin bit still. So in order to do that, we have to do the opposite. So it's a bit confusing. So we get x is going to be sine to the -1. The clue, if you've forgotten, is to look at the calculator, and above the sin, on the sin button, it says sin -1 when you're finding the angle. Whenever you're using the sine rule, sine's in there twice, isn't it? Can't ignore that. 5 sin 90 over 16. Put that into the calculator. Let's practice doing that then. Shift sin, put a fraction in there, 5 sin 90, close the bracket on the 90, go down underneath and put the 16 in, come to the end of the fraction and press the bracket button and equals, and that gives us 18.20, which means 18.2 degrees is our final answer. So now we move on to question 8. Pause the video and give this one a go. Right, so I know that this is 90 degrees, and that means, and I want the angle BAC, so that is there. So I've got that opposite there, but I do need this length, so I need to use Pythagoras here, and as this is the hypotenuse, a squared plus b squared equals c squared. You add together the two shorter squares, so 9 squared and 5 squared, and do the square root of that, and that gives it to you. Now if I put that into the calculator, it's not going to be very nice I don't think. No, it just says the square root of 106, and just use that as your number. Don't press S to D and start using that. It just means a lot of unnecessary writing. So the square root of 106. Now what do we know? We know that we want x, so that is an angle, so it's sine x over 9, because the 9 is opposite the x, equals sine 90 divided by that length, which is the square root of 106. So it's going to be a bit more than 10, because the square root of 100 is 10, isn't it? The square root of 121 is 11, so it's going to be 10 point something, or about 10.2 or something, I should think. Right, so now we have to multiply it by 9 to get rid of the 9 from being underneath our x, and we've got sine x equals 9 sin 90 over root 106. And then just like before, we get rid of this sin being multiplied by it by doing sin negative 1, and then we put all of this in. Remember, it's going to put brackets around your 90 degrees and your square root of 106 there, which should look something like this, and that will give you 60.94, so to one decimal place would be 60.9 degrees. And that's just about all we've got time for today. So in our last lesson before coming back, I'm going to go through the last few questions, which are not very many of them, but they're that little bit more involved. So we're going to take our time and we're going to go through them all, and I will or you will see me then. Okay, bye bye.